Alright guys, we're almost done. So relations and functions, and then we'll do average rate of change. So determine whether each relation is a function and explain why. So I'm going to look at this one first. Right here. So let's refresh. What does it mean for a relation to be a function? So each input is going to exactly one output. I know that sometimes my y values repeat, and that's not an issue, but my x values can never repeat. So remember the elevator example of, two inputs can go to the same output, but one input cannot go to two different outputs. And we think about that as like me and a friend are both inputs, and we're getting on an elevator, and whatever floor we're going to is the output. So me and a friend can go to the same floor. That's allowed. So two inputs can go to the same output. But I cannot go to two different floors at the same time. I'm just a person. I can't be two places at once. So one input cannot go to two outputs. Alright, so let's look. Basically, I'm just looking for repeated x values. This is the easiest way to think about it. So here I've got 1. Got -2, -1. Okay, here I've got 1 again. And so that's not allowed. This is not a function. Now I'm looking beneath that where it says f of x equals 2x plus 1. And it gives you the ordered pairs as well as a table. So whatever you're comfortable looking at is going to let you know whether this is a function or not. I'm just going to look right here at my x values to see if any of them are repeating. So 1, 4, 6, 7, 10. I don't really care if my y values repeat, and I just checked that my x values don't repeat. And so this is a function. And I also knew just by looking at this right here that it was a function, because 2x plus 1, it follows the y equals mx plus b, which is a linear function. So if you knew that, you could use that as well. Alright, now I'm going to look over here. This one, it tells me my domain and range. I know my domain is the set of all possible x values. My range is the set of all possible y values. Or you could think about it as input-output. So it looks like I've got 8, 5, 3, and 2 are all going to their own y value. I have 6 is a repeating y value, so 8 and 5 are both going to it. But that is equivalent to saying, me and a friend are going to floor 6 on an elevator, which is allowed. As long as one input is not going to multiple outputs, we're good, and I don't see that that's happening, so this is a function. Alright, let's look right below that at this one now. -4 is going to -1, seems fine. -2 is going to 3, seems fine. +2 is going to 3, also. This is the same situation. We've got two inputs going to the same output, which we don't have a problem with. And then 5 is going to 6, that's also allowed. So this seems to be a function as well. Alright, now I'm looking over here at this graph. When we have a graph like this, it's easiest just to use the vertical line test to see if I pass a vertical line through this graph, is it going to touch more than one spot on the graph? And the answer is no in this case. If you want to take your pencil across the screen or a piece of paper across the screen and use it as your vertical line to see, does it cross at multiple points? The answer is no, so this is a function. Alright, so now I'm going to look at this one. This, I'm going to use the vertical line test as well, but I can see right here, I'm just going to use a random example because there's multiple spots where it happens, but here's a vertical line that crosses the graph at two separate points, and so this lets me know immediately this fails the vertical line test, and therefore it's not a function. Alright, now this one we've done in class. How can you determine whether a relation represents a function? Just describe what you would do in each of these situations. So for a set of ordered pairs, you might do something slightly different from a mapping and a graph. What I'm looking for in this question is just like, do you know what you're talking about, and do you know how to articulate that? So for a set of ordered pairs, to tell whether it's a function, you don't want repeating x values. If you have repeating x values, then it's not a function. For a mapping, if you have anything repeating in the domain, it's not a function. But you can have values repeat in the range. For a graph, you would use the vertical line test. Now, these aren't the only acceptable answers for these questions. So whatever you said, if it works for you, then that's fine. I'm just looking for, can you explain your reasoning for why it's a function or not? The main point is you can't have repeating x values, which is the same as input, which is the same as elements of your domain, however you want to word it. Just be ready for the test to word it in different ways. All right, let's just move on to average rate of change. This is our last topic. You might see it in a graph, you might see it in a table, you might see it in an equation. So we're going to go through all of those. This graph shows the distance of an object over time, and it asks for the speed of the object. So this question requires you to know that speed is the rate of change of a distance versus time graph. So it's just asking what's the average rate of change. And I know, since this is a linear graph with uniform velocity, which is the same thing as speed, that my average rate of change is the same as my rate of change for the entire graph. And so it doesn't matter what 2 points I choose to do this. So I'm just going to choose points that I can clearly see. So I would call this right here 0, 0, and I would call, let's see, this one is slightly off, but I'm just going to call it 4, 3. So now, this is basically like when we talked about in class, using the formula. Let me remind you what the formula is, but you will need to know it on the test without being given it. So f of b minus f of a over b minus a, where a and b are the inputs, the x values, and f of b and f of a are those corresponding outputs. So I'm going to call 0 my a and 4 my b, which makes this other 0 my f of a and this 3 my f of b. Okay, so now I have all the values I need. I'm just plugging it in to the formula. So f of b I can now replace with 3. F of a I can replace with 0. B I can replace with 4, and A I can replace with 0. This is the same thing as 3 over 4, and that's our rate of change, or our speed, because it asked what is the speed. So 3/4, whatever it's measured in time and distance is what's going to be your answer. All right. So now we're looking at a table. It represents the depth of a diver in meters after X minutes of being in the ocean. So what's the average rate of change over the interval x equals 2 to x equals 20? So it gives me my interval. I know this is my A, and I know this is my B. So I'm interested in just this row and this row. So if this is A and this is B, then that makes negative 0.6 my f of A, and that makes negative 2.4 my f of B. So now I have all the values I need. I just need to remember what my formula is and then plug those values in. Alright, so f of B can be replaced with negative 2.4. minus f of a can be replaced by negative 0.6. Don't lose track of that negative and put negative 2.4 minus 0.6. Those are two negatives, so you need to have two. That will change your answer even if you know what you're talking about. So we can replace b with 20 and a with 2. So I know if I'm subtracting a negative, that's the same thing as just adding. So this is going to be negative 2.4 plus 0.6. So 0.6 plus 2.4 is, minus 2.4 is negative 1.8. 20 minus 2 is 18. And so when I divide those, I get negative 0.1. So the average rate of change over the interval from x equals 2 to x equals 20 is negative 0.1. So now we're looking at an equation. What is the average rate of change of this function right here? F of x equals 1/2 x minus 7 from x equals 2 to x equals 10. So this is my function, this is a, this is b. I need to find f of a and f of b myself using this. So f of a is just replacing x with a, which I know is 2. So f of a is actually f of 2, which is 1/2 times 2 minus 7. Half of 2 is 1, minus 7 is negative 6. Okay, so f of a is negative 6. Now moving on to f of b. b is 10, so f of b is f of 10, which is 1/2 times 10 minus 7. Again, I'm just replacing x with 10 in the function that I was given. Half of 10 is 5, minus 7 is negative 2. So now I have all the information I need. It's not as easy as when it's given to us in a graph in a table, but we are able to find f of a and f of b in order to plug it into our formula. So here we go. F of b can be replaced by negative 2 minus f of a can be replaced by negative 6. Make sure you're keeping track of both of those negatives because that's going to turn into a positive. Now b can be replaced by 10 and a can be replaced by 2. So negative 2 minus negative 6 is the same as negative 2 plus 6. So that's 6 minus 2, which is 4. 10 minus 2 is 8. I can simplify this to 1/2. And therefore, the rate of change of this function is 1/2. Last one, pretty similar to the one we just did. Here's my function. F of x is negative 6x plus 11. My interval is x equals negative 1 to x equals 3. And so this is a, this is b. I need to find f of a and f of b in order to use my formula. So f of a is the same thing as f of negative 1. F of b is the same thing as f of 3. Each of these, I'm just going to take the function that I'm given and replace x with that input value, a and b. So first is negative 1. So f of negative 1 is negative 6 times negative 1 plus 11. Negative times a negative is a positive, so negative 6 times negative 1 becomes positive 6. Plus 11 is 17. Now f of b is f of 3. It's negative 6 times positive 3 plus 11. Negative 6 times positive 3 is negative 18. And 11 minus 18 is -7. And so that's my f of a, my f of b. I have everything I need to use my formula. Replace f of b with -7. Make sure I have that minus. Replace f of a with 17. Replace b with 3. And replace a with -1. A negative times a negative, or not even times, just subtracting a negative is same as adding. So -7 minus 7 on top. Both of those are negative, so I'm going to add them and keep the sign. So it's -24. And then this is the same thing as 3 plus 1, which is 4. So -24 over +4. -6. Make sure you keep track of that negative. So -6 is the average rate of change of this function over that interval. Okay, so hopefully this study guide and the videos going with it make sense. If not, and you can't make sense of it even after the video, reach out to me and let me know. Look through your notes, and good luck on the test on Monday.